Welcome to Two Projects. In this video, we are going to explain the project Ship Detection Algorithm based on improved YOLO. So before diving into the execution, let me give you an overview of the project. So what is ship detection? So ship detection is identifying and locating the ships within the images or videos by highlighting them using bounding boxes or any other highlighter. So, ship detection is very important in monitoring maritime activities and ensuring safety at sea. For example, for maritime security agencies need to keep a close watch on ship movements to identify any unauthorized or suspicious vessels that may pose a threat to national security. So, by detecting and tracking these ships, authorities can take necessary actions to prevent potential security breaches or illegal activities such as smuggling or piracy. Similarly, for environmental protection, environmental agencies rely on ship detection algorithms to monitor vessel activities and prevent environmental hazards such as oil spills or pollution. And ship detection is also important for navigation and trading purposes. Shipping companies and navigation services use ship detection algorithms to track vessel movements, plan shipping routes, and ensure safe passage for ships navigating through busy waterways or congested ports. So, ship detection algorithms benefit various stakeholders, including maritime authorities, environmental agencies, shipping companies, and navigation services, and many more, by providing valuable insights into shipping activities and enhancing safety, security, and environmental protection efforts at sea. Traditional methods for ship detection encompass various techniques such as thresholding, edge detection, feature extraction, machine learning classifiers, etc. But these methods rely on simple image processing algorithms or manual inspection to identify ships within images or videos. So they face limitations in terms of accuracy, robustness, and scalability. For example, they may struggle with complex backgrounds, varying lighting conditions, which may lead to false detections or missed ships. Additionally, manual inspection or simple algorithms can be time consuming and error prone, especially for large datasets or real time applications. So, there comes convolutional neural networks, the deep learning. So, convolutional neural networks have revolutionized ship detection. They automatically learn and extract relevant features from ship images, enabling more accurate and robust detection. So, we will be building CNN based YOLO algorithms in this project. Now we have seen why is ship detection important. Now we will see what we have done in this project. So, we have used ship images to train the models. Before training the models, we have performed pre processing. So, pre processing the ship dataset involves getting it ready for training ship detection algorithms. First, we make sure all the images are in a format that the model can easily understand. Then we resize the images to same size so the algorithm can work with them efficiently. And we also adjust the colors to make sure the algorithm can see them clearly. Additionally, we add more variety to the dataset by making slight changes to the images like flipping or rotating them. So this is called data augmentation. So we'll perform data augmentation so that the models can generalize to any situation. Finally, we organize information about where ships are located in the images so that the algorithm knows what to look for. So, this pre processing makes the dataset consistent and diverse, helping the algorithm learn better and detect ships accurately in different situations. So, now after pre processing, we will input the pre-processed images into different YOLO versions: YOLO V5, YOLO V6, YOLO V7, and YOLO V8. After training these models, we will compare their performance using metrics, MAP, precision, and recall to select the best performing model to detect the ships. So, this is what we are doing in this project. Moving on, now we'll see the software and hardware requirements. So, hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language needed is Python, front-end framework required is Flask, back-end framework needed is Jupyter Notebook, database required is SQL Lite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we'll see the algorithms built. So in the base paper, author has proposed YOLO V5. For improved performance, we are proposing YOLO V6, YOLO V7, and YOLO V8 in this project. So YOLO, that is You Only Look Once, is a computer vision object detection algorithm that quickly identifies objects in images by splitting the input image into a grid format and simultaneously predicting bounding boxes and class probabilities. Unlike traditional methods, YOLO processes the image just once, making it extremely fast. It predicts multiple bounding boxes and their associated class probabilities for each grid cell and then removes redundant detections using non-maximum suppression. So this results in a final list of detected objects along with their bounding boxes and probabilities. So these are different architectures. Although they have similar objectives, they differ in their architectures. So YOLO V5, it is known for its balanced performance between accuracy and speed. So this version relies on a backbone network called CSP Darknet 53. It utilizes focus modules for downsampling and path aggregation network, that is PAN, for feature fusion, enhancing object detection across different scales. Coming to YOLO V6, this model introduces a key difference by using Efficient Net L2 as its backbone network. Compared to Efficient Net used in YOLO V5, Efficient Net is known for its efficiency with fewer parameters. So YOLO V6 also employs a novel dense anchor box generation method to improve object detection accuracy. Next, coming to YOLO V7. YOLO V7 uses a modified version of the Swin transformer architecture as its backbone. So this architecture leverages self-attention mechanisms, leading to better feature extraction compared to convolutional neural networks used in prior versions. And the next one is YOLO V8. It is the latest version focused on facilitating performance comparisons with older YOLO models. So YOLO V8 also introduces a unique loss function and an anchor-free detection head, which are technical improvements to the overall detection process. So we will build all these models. After building them, we will compare their performance using MAP, precision, and recall metrics. So the best performing model will be selected. So after doing all these, we have observed that YOLO V8 has outperformed all other models in all the performance metrics, MAP, precision, and recall. So we will be deploying YOLO V8 in Flask framework. Before executing the project, first we need to open the code folder which contains the project source code files. So this is the code folder. This is dataset folder in which I have train and test sets. So train set is used for training the models and test set is used for evaluating their performance. So in train folder, I have two subfolders, images and labels. I'm opening images folder. So these are different ship images I have in different angles and colors. So we will be using this dataset to train the YOLO models. And this is labels folder in which I have files containing annotations or labels for objects in the corresponding images. So each label file corresponds to an image file in the images folder. So this file corresponds to this image. Similarly, this label file corresponds to this image. Okay, so each label file corresponds to an image file in the images folder, providing details about the objects, locations, or classes within the image. So these label files often follow the YOLO format, where each line represents a detected object. So each line specifies the object's class index. This is the class index. So class index could be whether it is a cargo ship, or it is a fisher boat, or it is a passenger's boat. So it could be any class, followed by bounding box coordinates normalized to the image dimensions. So these are the bounding box coordinates. This is the x limit, this is y limit, this is width, and this is the height. So these are total detections made in the first image. So there are 15 objects, 15 ships detected in the first image. So similarly, I have class index followed by bounding box coordinates normalized to the image dimensions in the other label files also. So using these datasets, the images and labels datasets, we will be training the YOLO models. Similarly, I have images and labels folder in test folder also. So on this dataset, we will be evaluating the model's performance. So this is sample folder in which I have images again. So on these images, we'll make the detections. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And this is model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained models. And this is Notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the file explorer. This is the path, copy it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So this is the front end. Here we can see a sign up link. Click on it. If we are new users, we have to register ourselves first, fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the detection page. So here we have to upload any ship image and the application will detect the ship from the image. Click on choose file button. Select the image from here from the sample images folder. I have selected the image. Now click on upload button. So we can see the application has detected all the ships. It has drawn a bounding box around the detected ships and it has classified them as fishing boats, and we can see a probability score here telling us the confidence level, how confident the model is about the classification. Click on back. We'll try with another image. Click on choose file button. This time I'm selecting this image and click on open. The image is loaded. Now click on upload button. So we can see the application has detected these three ships. It has classified them as fishing boats again, and we can see the probability score here. Click on choose file, select the image. This time I'm selecting this image. Click on open and click on upload. This is the uploaded image, and we can see the detections here. The bounding box is drawn around the detected ships, and we can see the classifications. So this time we'll upload this one. Click on open. The image is loaded. We can see this time the application has detected three ships and classified them as passenger ship, bulk cargo carrier, and another one is also cargo carrier. So we can see the difference here. It is differentiating the ships with different colored bounding boxes, passenger ship with green colored bounding box, bulk cargo carrier with red colored bounding box. And we have seen the fishing boat has been detected with a orange colored bounding box. Click on back. We'll try with another image. This time I'm selecting this image. Click on open. We can see the application has classified the ships. This is classified as bulk cargo carrier. We can see the bounding box drawn around the detected ship. And here we can see another bounding box drawn for fishing boat. Click on back, choose file, select the image, click on upload. We can see the application has classified the ships, has detected the ships and classified the ships. This time I'm uploading this one. So we can see the detection. The application has classified the ships as passenger ship and general cargo ship. And we can see the probability score here. Click on back. So similarly, we can upload any image and can get the detection and classifications. This time I'll be uploading this image. We can see the detection. It has drawn a bounding box, the red colored bounding box, and classified this ship as bulk cargo carrier. And we can see the probability score. Click on back. So we can take the images from Google also. We can make the real-time detections also. We'll try that. We'll take the images from Google. So I'm selecting this image. Download this image. Upload the download image here. The image is loaded. Now click on upload button. So we can see the application has classified this ship as container ship. It has drawn a bounding box around the detected ship, and we can see a probability score here telling us the confidence level of the model in classifying this ship. Click on back. We'll search for another image. We'll upload this one, download it. Select the image, click on open. So this file is not supported. We should only upload JPEG and JPG files. Choose another image. We'll upload this one. Click on choose file. Select the downloaded image, click on open and click on upload. So we can see the application has classified this ship as passenger ship. It has drawn a bounding box around the detected ship and classified as passenger ship. And we can see the probability score here. Click on back. We'll try some more images. We'll upload this one. We can see the application has detected and classified this ship as bulk cargo carrier. We can see the bounding box drawn around the detected ship. Click on back, choose file. Sorry, we have to first download the image. We'll try with this one. Select the file, click on open and click on upload. So it has not detected these ships. We'll try with another image. We'll try with both images. Click on choose file, select the image, click on open and click on upload. We can see the application has detected the ship. It has drawn a bounding box around the detected ship and it has classified this ship as fishing boat. And we can see the probability score here. So in this way, we can take the images from Google also and can get the detections. Click on sign out. So we have to upload the images and can get the detections.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.